Okay, Foundations in Math 11. Here we go. Video 6. We're talking standard deviation. So, standard what? Standard deviation is how far we deviate from the mean, so from the average. And we're going to look at this a little bit closer when we get into the normal curve. This is an example of what a normal curve looks like. We're going to look at this in the next video, but I just wanted to show you that if the middle here is the mean, right? Here's the mean. This is the mean minus that funky symbol is a symbol for standard deviation. Kind of looks like that. So if you're within one standard deviation of the mean, you are either above it or below it. And then when you're two standard deviations from the mean, and then you are three standard deviations from the mean. So as you can see, the more standard deviations you are away from the mean, the more rare you become. Right? Most of the data exists in this part of the graph. Very little data exists down here. So when you hear talk about standard deviation, you're looking at how far away is the given data from the mean. If you are three standard deviations from the mean, you are quite far away from the mean. You're in more obscure territory. So the equation for standard deviation is quite cumbersome. You need all of your data points. So that's what the x1, x2, xn mean, however many data points you have. You need your mu, so that is the average of your population, because you're going to be given an entire population worth of data. And then you need the n. So we got to do quite a bit of calculating here, that we square root the whole thing, so there's lots going on. So follow along, I'll do two examples, but I'm going to cut them a little short with respect to the inside chunk, but just so you can see the inner workings. So here's an example. We got a whole bunch of test scores here, okay? 65, 70, 52, 86, 90, 89, and 72. What is the standard deviation? Okay, well, the first thing we need to know is we need to know mu, which is the same as x bar. Mu is the mean of our population. X bar would be the mu of our sample. But in this case, this is our population. This is all the data we have. So we need to find the average. So we're going to add all these things up, and I'm going to shorthand this by saying, okay, this plus, and then all the things added together, then plus my last number, and we're going to divide that by the number we have, which is 7. And we end up getting an average that is 74.8. But for the sake of the calculation here, I'm going to round that up to 75 because it's going to make things a little bit easier. So there's our average. Okay, so what we have to do now is we take this big rooted statement, okay? The standard deviation is equal to our first term minus our mean squared plus our second term minus our mean squared and our third term minus our mean squared all the way to our last term, so in this case x7 minus our mean squared. All of that is then going to be averaged underneath my root symbol. So I've shorthanded that for you here. Your standard deviation, let me get the symbol accurate, there you go. So my standard deviation is equal to, in this case, I'm only going to show the first few, all right? The square root of 65, that's my first number, minus my average, squared, plus 70 minus my average, squared, and then all the rest, and then plus 72 minus my average, squared. And then I'm going to divide all that by 7. So if I work that through, I end up with this. I end up with the square root of negative 10 squared plus negative 5 squared plus negative 23 squared plus 11 squared plus 15 squared plus 14 squared, and then plus negative 3 squared. And I don't know why I put brackets around all the positive numbers, but brackets around the negative numbers help because the good thing about negatives in this case is they're always going to square out to be a positive number. Because if that didn't happen, it's possible we could end up with negatives underneath our radical, which isn't allowed, and everything would break down. So the squaring is really, really important. So we get the standard deviation, and now we can kind of total these out. 100 plus 25 plus 23 squared, which is 529, plus 121 plus 225 plus 196 plus 9, all divided by 7, and yeah, all still underneath your radicals. So you can see this is a really tedious equation, which is why we're only going to crunch this a few times. So then my standard deviation, I'm going to add all those numbers up, and I get 1205 over 7, which gives me the standard deviation is the square root of 172.1, which gives me 13.1, which I will round to 13. So what does that mean? That's a lot of work to do just to get that number. Well, I'm going to erase this stuff here on the left because we've worked through all that. And if you consider it with respect to your mean, the mean we calculated was rounded to 75. So that means if we had these test scores, right, and this was my middle, my average, 75, if I was one standard deviation away, I'd be here, 13 away, so I would be at 62. And if I was 2 standard deviations away, I'd be in that fail territory, unless your teacher's nice, which they should be if you have 49. But if you're 2 standard deviations away, there you are, you're at 49. If you're 1 standard deviation away in the other direction, well, it's still 13. This time we're up now to 88. And then if you're 2 standard deviations away in the other direction, you're now at 101. So you can see that the more standard deviations away you are, that's sort of how the standard deviation spreads. So that's what this number tells you. It tells you the distance spread of those standard deviations. So it's going to come in handy when we look at the normal curve later. Now, this is sort of again, we'll look more at this in the next video, but this is the normal curve, the breakdown. And really the breakdown that I want to highlight here is that if you are within 1 standard deviation of the mean, either positive or negative, that is comprised of 68% of your data. So the probability of you lying within 1 standard deviation of the mean, 68% of the people would. So 1 standard deviation of the mean is quite normal. If you get to 2 standard deviations of the mean, right, and you combine that, that's another 27.2%. So you're up to 68.2 plus 27.2, like 27.2 and 68.2. Don't want to send you for a ride here. That's 95% of all the data. So when you get to these little wings on the end here, within those 2 wings, once you're more than 2 standard deviations away, that only comprises about 5% of all the remaining data. So that's why those are outliers, and that's why those are pretty rare scenarios, because once you're multiple standard deviations away, things start to get pretty obscure. Now, your normal curve doesn't always need to look exactly like that. I'll just show you. Depending on your standard deviation, your curve will either be really tall and skinny, or it can be really, really spread out. Because remember that the standard deviation is how far away you are from the middle, and it's per standard deviation. So, right, this first one in the middle, the really tall one, you're only 1 standard deviation away, you're only 5 away. So 1 standard deviation is only about that far. Right, and then 2 standard deviations. So if the standard deviation is a small number, you have quite the narrow peak of a graph. If your standard deviation here in this case was 10, you can see the graph gets a little bit more spread out. And then as your standard deviation gets really large, well, here we get a really sort of small, slow incline normal curve, because the spread of the data is just so much more spread out. Now you're still going to get your extreme wings, right? You're still going to get those extreme wings of data, regardless as to whether or not your circles, your standard deviations are large. It just means your curve is a little bit more flattened. All right. So let's do one more example of calculating the data, and then we're done here. And I'm really going to shorten this one down for you. First thing we need to do is we need to add up and find our mean. So 2 plus 5 plus 8 plus 11 plus 14 plus 17. So 1, 2, 3, 4, 5, 6 numbers. So we're going to add those numbers up. We get 57. We divide 57 by 6, and we get 9.5. So 9.5 is our mean. I'm going to write it up here because I'm going to want that room. So I'm going to erase that work. So we found our mean. Now we need to take our mean, remember, and subtract it. We have to do the x1 minus mu squared, followed by all the rest, all underneath the square root symbol. So what you end up with in this case, I'm going to stop drawing the arm on the end because quite often I need to go a little bit further. If you do 2 minus 9.5, so we're going to have negative 7.5 squared, and then 5 minus 9.5 is negative 4.5 squared, and then we're going to have negative 1.5 squared, and then we're going to have positive 1.5 squared, and then positive 4.5 squared. And you can see a little pattern here, and then positive 7.5 squared. So that's our data. If we multiply all that data, if we square all that data, and remember that data is then going to be divided by 6. So if we square all that data and add it together, we get the square root of 157.5 over 6, which simplifies to the square root of 26.25, which then comes out at a standard deviation of 5.1. So this is a rather small standard deviation. Our normal curve would be relatively steep because our data is not overly spread out, but there it is. So that's standard deviation. The next video, we're going to look at the normal curve, and we're going to look at how we can use z-scores and probability to narrow down this standard deviation talk, and we can start looking at the percentage of finding data to the left of our value. So normal curve is coming up next, and then we're going to look at confidence intervals for our last section. So thanks so much on this one. Remember, you can find the notes. It has a bit of number crunching in there and a few examples to practice your number crunching. Again, there are great programs that do this for us, but while we're learning it, it's helpful to, again, get our hands a little dirty and just try to hammer it out old school. All right, so thank you so much, and I will see you next time.